The purpose of this analysis is to evaluate the oxygen permeability of a flexible film. Many food products, such as coffee, dry nuts, olives, and various sauces, as well as cosmetic products like facial creams and rinse-off formulations, must be protected from oxygen to extend their shelf life and maintain their freshness over time. One of the primary functions of the packaging material is to prevent oxygen from coming into contact with the product. This analysis, known as the oxygen transmission rate or O.T.R measurement, is performed using specialized analytical instruments. Measuring the O.T.R of a packaging material is essential for determining how long it takes for oxygen to enter the package and reach the product. To begin, the sample is cut to specific dimensions and conditioned at ambient temperature in a desiccator for at least 48 hours. And the operator ensures that the correct sealant is applied. The specimen is then mounted in the test chamber. Test conditions are selected based on the final application or according to customer requirements. The instrument first applies a vacuum on one side of the specimen using pure nitrogen, removing all oxygen from the chamber. Next, a controlled amount of oxygen is applied to the opposite side. During the test, oxygen permeates through the material and eventually reaches the clean side, where only pure nitrogen is present. A coulometric sensor measures the voltage difference between the nitrogen and the oxygen-nitrogen mixture. The analysis continues until a steady state is achieved and the sample reaches equilibrium, which typically occurs within 15 to 48 hours depending on the material. Using a calibration curve created prior to testing with standard materials, the instrument calculates the transmittance value. Each sample is measured twice to ensure repeatability and reliability of the results. The O.T.R instrument can also measure in humidity conditions. The units of O.T.R are expressed as cubic centimeters of oxygen per square meter of material per day. A low O.T.R value indicates a strong barrier material, one that effectively prevents oxygen from entering the package and degrading the food or cosmetic product. Materials used in flexible packaging that typically achieve low O.T.R values include aluminum, ethylene vinyl alcohol, metallized films, and specialized coatings such as aluminum oxide. In contrast, base polymers like polyethylene and polypropylene are highly permeable to oxygen. As a result, they exhibit high O.T.R values and allow oxygen to reach the inside of the package, a characteristic desirable for certain applications, such as fresh produce. The key is aligning the film's barrier performance with the product's shelf life requirements and sensitivity to oxygen. If you supply packaging to a brand or food manufacturer, you need to know: does the barrier meet the specification? Is there a risk of oxygen ingress causing spoilage? And is there room for optimization, either reducing barrier to lower costs if storage conditions permit, or increasing it when shelf life performance is insufficient? At PackLab, we have expanded our in-house testing capabilities with this advanced instrument. This enables faster turnaround times, precise and reliable data, and the ability to test a wide range of materials, from films, laminates, and foils to paper-based barrier structures. We operate in accordance with internationally recognized standards, including ASTM D3985, ASTM F1927, and ISO 15105-2. Ultimately, precise oxygen transmission testing provides the assurance that packaging will perform as expected in real-world conditions. By relying on accurate data and proven standards, producers can safeguard product quality and deliver greater value to their customers.